All right, welcome to the after work video. This schedule is working out pretty well for me, so let's keep on going with it. I'll share my second screen, and you can see the notes I've got from the last video. We were doing the verification steps, so let's keep doing those and get a better sense for what this example is even asking me to do, because I was just wondering, like, what does it mean that a route has been leaked? Because we could see in the routing table of router 5, there was no difference whether the route was leaked or not. And we can tell that the route was leaked. So if I do a show route, and now I look at the routing table, we don't see any specific route for the route that was leaked, and that is 192.168.0.3 is the route that was leaked. And we know that it was leaked because they gave us verification steps in the example. So one of the steps was to take a look at the ISIS database on router 1, and then if you see this internal down, then you know that the route was leaked. But if it's internal up, then the route hasn't been leaked. So I mean, that really confuses me, because, like, yeah, I just don't understand. Well, let's run that command again to make sure that it does match what's there. Show ISIS database detail. So yep, it matches exactly what was there. So the routes were leaked. Let's see what it looks like without having leaky routes. So you can see if I go over to router 5, do a show route again, there's no difference. It looks exactly the same. All we've got is this default route, whether we are leaking or whether we are not leaking. But we can see there is a pretty big difference. When we are leaking, we will have internal down. When we aren't leaking, we will have what we have here, which is quite a bit different. Let's just grab this whole thing and then do like a compare in Notepad++ and really see what the differences are. Okay, I got a bunch of stuff open. Oh, and I've got it set up on this computer to not automatically save. I don't even know how to do that. Okay, there we go. So now I need to grab the other one, which is up here, I believe. Yeah, I think this is the whole thing. So it's quite a bit more. I guess I'm not sure if this is the whole thing, so I'm going to roll back that and just make sure I've got everything I need. Okay, and I'll give it a little bit of time. And then, well, I'll just print it out now. Okay, yeah, it looks like it's what I need right now. So let's get that whole thing. All right, so now I've got Notepad++ open. So let's use the compare plugin and see what the differences are. So, oops, and I did not mark. So this is obviously the one where with leaking, because this is what matches the verification steps. So they have been leaked here. They have not been leaked here. So we can see we've got things that are different here, but this looks like it's just the lifetime, the checksum, all of that, of course, is going to be different. It's just specific to the actual time that I ran it, that sort of thing. So it's really nothing to notice that these are different. In fact, due to my coloring rules, it just completely blanked it out. I can't even see it. But that's fine because it doesn't matter. So we can see before I was leaking, we didn't have anything in level 1. But after I'm leaking, we do, but they are down. So I think the point of this is just to show a policy. It's not necessarily to show a policy that you would necessarily use in the real world. It's just to make a policy and then prove, yes, this policy worked because now you have routes that were previously in the level 2 link state database. And we can see here's one of them. And yep, so then, and of course, they're going to belong to the router they came from. So here's the other one associated with router 2. Here's one associated with router 3. And one interesting thing to know is that the ones associated with router 3, we don't merely have the IP address for router 3, we have it for router 4 and router 5 as well, because router 3 is in between the levels. So these are going to be, even though they're from level 1, router 3 has the capability to forward them on to level 2. The other thing to notice is that the metric increases when that happens. So that explains why these show up as metric 10, but those show up as metric 20. So let's look at that again. Show route protocol ISIS. So we've got these, they're metric 10, and these, they're metric 20. And that's because they came from level 1, so they've got an extra 10 metric, but these came from level 2, so they don't have an extra metric. And then they just always get a 10 metric whenever they move. Okay, so let's see here. So yeah, we can see, yes, there are those routes in level 1 now, so we leaked them, but I don't think we did that in a manner that is useful or matters. So let's, yeah. They've been successfully leaked. Route leaking from a level 2 to a 1 area is functioning as expected. Okay, well, let's cross that off. So I'm going to take these, I'm going to copy these down and put them here. And then I'll add the tags down there. I might take the Wireshark tag out, but I'll probably use it by the end of the video. I'll leave it in. But yeah, so I'm gonna cross this one out, but before I move on to the next one, I'm just gonna figure out why you would need to leak a route. So let's expand all and go to leak. Well, first let's just go to the guide so we don't get any false positives. Okay, so all we get is an example showing us how to leak a route, but we don't know why to leak a route, aside by because you want information from a level 2 area to go to a level 1 area, but we saw very clearly that information did not go to the level 1 area. And in fact, I would be surprised if that were even possible if you did that on routers that were only in level 2. I would think you would need to do that on this router. So if it gets to the test and I get a topology like this and they tell me to link routes from level 2 to level 1 and I'm expected to do this and I don't see the routes in level 2 to level 1, well, I will definitely say I will not pass that because there's no feedback to tell you whether you've done it right. I mean, you can look at the database and you can see that you can see this, but like what's the point? So let's figure that out. Let's do a Google search for why you would leak ISIS routes from level 2 to level 1. Okay, so this looks pretty good. The other thing that I kept note of a while ago, and I believe it's up here somewhere. I hope it's up here. Yes. So I found a great kind of all-encompassing resource for ISIS. It's from iNet0 here. It's just available online through a Google search. So it's just somebody's personal blog that's public. So let's see what this has to say about leaking, because this looks like a great source. So ISIS routes leaked from an ISIS level to another. So yep, they're going to devote a whole section to this. Oops, but I think they're just going to call it leaking. There we go. All right, so yep, so here we go. So this should be enough. And unfortunately, I will need to take like a 5-minute break, but I will be right back. All right, we are back for this. Yeah, sorry I had to step out. But let's do, yeah, so let's learn why you would even need a leaking policy to go from, why would you want that? So let's see here. So inter-level routing on multi-area topology, some routes are leaked between levels. The default behavior is the following. Leak only internal routes from a level 1 area to a level 2 area. Leak nothing from a level 2 area to a level 1 area, but a L1/L2 router set a specific flag attached bit within its level 1 LSP. Label switch path was a, I don't know what. Oh, right, yeah, LSP has its own special ISIS meaning. That means I know the backbone. You can use me as a default gateway. So that's why it's got that default gateway route, all the level 1 routers. Yep, so, but on a level 1, level 2 router, set a specific flag attached bit within its level 1 LSP. That means I know the backbone, you can use me as a default gateway. So pure L1 nodes receive from L1, L2 nodes a kind of default gateway. And we've seen that. That is self-evident in our topology here. This is that. Let's try to find that attached bit too. Maybe we can find it in some of the, show ISIS database detail, but of course we're going to only find that on a level 1/level 2 router, which is router 3. But let's try to find that. Okay, so we're looking for the attached bit. So it's going to be in the L1. So I guess having Wireshark is appropriate because I'm going to need to do a capture here to look for that attached bit. Okay, so not sure where this will show up. So they said it's going to be in the LSP, right? Which of course means something specific to ISIS. Let's look up what it means for ISIS. I mean, I can probably do it here. So oops, well, closing the tab isn't going to help. I meant to duplicate it. I meant to do basically the opposite of what I did. Okay, so let's find LSP. So link state PDU. So link state PDU, maybe we can find that here. So these are entries. Let's do maybe a selected. No. Let's do, okay. Link state PDU. So I think we're not getting link state PDUs right now because there's no change in the link state. I think if I change one of the link states, we'll get a link state PDU. So let's try that in my second screen here. So I won't be able to see what I do, but I'm just going to disable one of these links here, and we'll be able to see the more important part anyway, and that's the links actually changing. So I'll disable the link to router 4. Okay, so hopefully we'll see an LSP, a link state PDU. Aha, we do, perfect. And we'll probably see the attached bit now because this is a level 1, level 2 router. Aha, here it is, the attached bit. We got an error metric, delay metric, default metric. So, well, it's attachment. I don't know if that's the attached bit or not, but I assume it is. I mean, what else would it be? It's the only thing that says attach. Okay, so yeah, I think I'm good with that. I'll roll back my configuration. We'll get another LSP because it's a link state PDU, so it's going to tell you about all the changes to the links within the level you are in. And of course, if it's a level 1, level 2, as these are, it's going to have an attachment bit. Oops, it looks like, here we go. So now we've got multiple LSPs. Oh, we've got one with the attachment bit set and then one without. So yeah, only the ones coming from the level 1, level 2 are going to have the attachment bit set. So we know this 004 is from level 2. Yep, and the level 1, level 2 router. Yep, and we can see that because the LSP ID is 0003. So yeah, so that one's going to have the attachment bit set. But this default behavior could be overridden in case of using specific export policies, wide metric only knob changes all the prefixes conveyed by ISIS as internal routes. This includes redistributed routes, new style TLVs that don't keep the E/I flag anymore. And I'm not sure what a TLV is. Let's look at that. Yeah, it's a type length value field is what I thought. That's what I thought it was. So there should be TLVs somewhere. Huh. Okay, well, I don't know where. So let's go back here and say when you want to modify the default leaking policies, you might trigger routing loops. For example, a /32 leaked from level 2 to level 1, then leaked back from level 1 to level 2, and so on. This is not possible because ISIS includes a specific flag per IP reachability, aka per prefix, which informs if a prefix has been leaked. This flag is called the distribution bit, aka up/down. When a route is leaked by a policy from the level 2 to the level 1, the up/down bit of this route is set to down, which means that the route comes from level 2, that a down route can never be leaked back from level 1 to level 2. Okay, well, why didn't it? Notice a policy which modifies the level 1 to level 2 leaking never modifies the up/down bit, which will still be set to up. Okay, so the way they think about it is, yeah, okay, well, yeah, okay. On Junos, you need to create your own policies and apply them at the ISIS export level to change the default leaking policies. Hereafter, an example where all the /32 are leaked from R1 to R2 and R2 to R1. Remember, automatically down bit is set for routes that match L2 to L1 policies, which avoids routing loops because the default behavior is for it to go from level 1 to level 2. So if you don't have that mechanism, it'll go from level 2 to level 1 for your custom config, but then the default behavior will send it back and you'll have that loop. So that is a good feature. Okay, so here's I think hopefully a better example of this. But one thing they're not doing though. So yes, they are. Yes, so you can see, yes, my confusion was correct. I think it might, I haven't, Norman, I think I got to put Norman to work. I think he's had too much time off. So, yep, I'm going to have to download this article because I really don't get why you would put a leaking policy on an internal route like here. And this shows that L1 down routes are rejected even if they're matched the L1 to L2 policy. L1 to L2 policy. Yeah, you see these policy arrows are on these devices, which are in between level 1 and level 2. They likely have, I mean, these bubbles are so bad because they need to be like intersecting here. Like it's just not clear what is going on here. Is there a level 1 adjacency between here and now this is a level 1, level 2 router? Oh, I see. Okay, so they are labeled here level 2. So these have level 2 adjacencies, and these are level 1, level 2 routers, and then they have these special arrows on them that says that it has the level 1 to level 2 policy, which is the default policy, but our policy level 1 to level 2 is going to set that bit to down. As we saw in the lab, we did see that behavior, and that's really important to take note of. So let's look at that again. It was on router 1. So show ISIS database detail. So yep, here it is, the up-down bit. Really important to have this, otherwise we would have loops, but we are configuring these policies on the internal routers, so this makes zero sense to do at all. Let's go ahead and try to fix this by configuring it on router 3. So we'll remove these policies from router 1 and router 2, configure it on router 3, and then let's submit a downvote, and that'll probably be 20 minutes, so that'll be the end of the video for today. Hopefully I can get all of those things done. All right, so here's the policy that we had before. We're going to need to change this up, of course. Let's go on router 2 and just clean that up before we kind of dive into the more difficult part and see what router 3 will need to look like. All right, so router 2 looks good. Oops, I never hit commit on router 1, so I will do that now. All right, so now for the fun part, we'll actually try to leak the the route instead of just set up the policy and technically have it leak, but not have it actually do anything. So let's try to make this tiger have some claws. All right, so yeah, we can't really just do this. I mean, I guess we can. Yeah, no, this is exactly what we can do. Let's just do exact, and then let's just leak the exact route we want to leak. We'll only leak the loopback address from router 1, and that will be totally fine because, yeah, so we're going to do, if it's from ISAS, if it's level 2, and if it matches this, then we're going to set it to ISAS to level 2, and we're going to accept it. So I believe this is all we're going to need. Okay, so we're good to go. Now, hopefully we can see the value of leaking, which usually doesn't have any value. guess like a, all right, so let's do a show route. Oops, so yeah, I don't see it leaked. Yeah, it appears not to have leaked. Let's do a show ISIS database detail. Oops, and it looks like it's still internal up, which is interesting too. Okay. Yeah, I don't see anything registering as down, so yeah, I don't think it leaked because now do we have an exact match? Let's see. Yes, right here. But it's internal up still, it's not internal down, so it would have to be internal down, otherwise there'd be a routing loop. So is there a routing loop now? Why is it not internal down? Why is it not internal down? And why is it not showing up here? Nothing's working. Maybe it has two hidden. Nope, no hidden routes. Huh, I don't understand what's happening. Oh, now I do. So that's the eagle eye. That's good. I'm going to need to have that kind of eagle eye in the test. So if anyone wants a better explanation, I'm saying it has to be this exact route with 24 bits in the networking portion, but the route actually is a /32. So /24 is not the exact same as a /32. If I did or longer, then I would have had a match, but I changed it to exact. Yeah, because there's it was a pretty big clue that it didn't change to down. It was still up. It was clear that the route just simply had not been leaked for some reason. So there was a flaw in the leaking policy. Okay, so now the route will hopefully be leaked. We can check that just in the ISIS database, show ISIS database detail. Aha, so yep, the route is now officially leaked. So now that we have it in a area that is more advantageous, we can see the actual advantage you do get from leaking. Sure enough, so now you get, instead of just having to rely on this, you get this extra route here. So you can take individual routes from level 2 and you can send them individually in level 1. You're not just restricted to relying on this default route here. And a big reason why you can do this is because the show ISIS database detail, it's because of the mechanism here where you have up and down, and you will change it to down so it knows not to send it back to level 2 and not to cause routing loops. So cool, I really think I learned a lot in this video. I learned way more about ISIS. I actually feel pretty comfortable in ISIS, at least with route leaking. I understand why you would want to do it. I understand how to do it. I understand where to do it. I understand when to do it. So So why you want to do it? Because you want a more granular route. You want more control of where your traffic actually goes instead of just relying on the default route. Where you would do it on a level 1/level 2 router, which is something I'll be submitting a report, a downvote on the documentation for. When you would do it, well, I guess whenever you need it. You probably would need to do a, yeah, I mean, you definitely want to do anything relating to IGPs in a maintenance window. You wouldn't want to, if there's live traffic, I mean, anything like this, like pretty much, if you're in a paranoid enough environment, they'll want you to do a description change in the maintenance window, just if they're paranoid enough. So yeah, you would do this. As far as when you would do this, a maintenance window. And then, yeah, how you would do it, we saw very clear. It's just a policy. You've got to match the protocol. You've got to match the level. And then you've got to use a route filter to match the routes you want to leak. And then you've got to send them to protocol ISIS. That could be an easy one to forget. And then you've got to send them to level 1. And then you've got to do a then accept. So it's going to be from protocol ISIS, from route filter, from level 1. Then it's going to be to protocol ISIS, from level 2, because you don't need a policy for the other one, it does by default. So it's going to be to protocol ISIS and to level 1, and then a then accept. So let's take a look at that to verify. Oops, so we're going to need to, let's just do the whole thing. Oops, and okay, this is the wrong device. Yep, so it's going to be from ISIS, from level 2, from whatever route filter you need for whatever routes you want to leak. I guarantee you this will be, something like this will be on the exam, so I'll need to carefully read the exam and make sure that this is correct. This is where I could have a reading mistake where I think it wants exact or something like that. And of course, I got to be really careful if I'm using the exact keyword or any word really, that I'm using the appropriate subnet mask. And then to protocol ISIS, which could be difficult to remember because it already came from there. So it might be hard to remember that you still need to specify that as the to, even though you have specified as the from. Then to level 1, that's easy to remember because this is the whole point. And then accept, that could be difficult to remember as well. And it's probably just, no, I think you probably do need a then statements. I don't know, but it's definitely better to include it, even if it's not necessary, just to make it more clear what the policy is. And then you just export it into protocols ISIS. So real easy. There's only about 8 minutes left of this video. Usually I go until 6 for the after work video. So I can end a few minutes early, but before I do that, I will leave a downvote on this article because it's just, well, I'll leave a super upvote on this. This is amazing. But on this, unfortunately, I will need to leave a downvote. And I'll put my email there. And I'm sure Norman will be happy to hear from me again. It's been a while. Hope he's doing okay. Hope he's wearing a mask at work. So let's go ahead and, yeah, leave good a good downvote. So there is no reason to configure a a route. There's no reason to configure a route leaking policy to configure an There is no reason to configure an ISIS route level 1 to level 1 route leaking policy on internal routers. The policy belongs on router 5, the L2/L1 router, and not R3 and R4. Since these are L2 only routers, even though you can still technically leak a route and see it show up as down in the ISIS database, such an example is confusing because it does not show the full results of a leak. Does not show if it were configured as would be shown, as could be verified by checking the routing tables of either of R6 and R7 if the policy were configured on R5. Okay, I think this is pretty good. So let's read it over once, get a good first spelling, and then hit submit, and then that'll be the end of the video. I'm a few minutes early. I kind of got a stomachache anyway, so it'll be good to end it a bit early. There is no reason to configure an ISIS level 2 to level 1 leaking policy on internal routers. The policy belongs on router 5, the L2/L1 router. Router, not on R3 and R4. Since okay, let's start again here because that was not very good writing. There is no reason to configure an ISIS level 2 to level 1 leaking policy on internal routers. The policy belongs on router 5, the L2/L1 router, not on router 3 and router 4, since they are level 2 only routers. Even though you can still technically leak a route on an internal router, even though you can still I wish I could make this bigger. I can't. Well, let's take it out of here and put it into like WordPad. Okay. Okay, so there's no reason to configure an ISIS level 2 to level 1 leaking policy on internal routers. The policy belongs on router 5, the L2/L1 router, not on router 3 and R4, since they are, okay, and I'll just say, there is no reason to configure an ISIS level 2 to level 1 leaking policy on internal routers. The policy belongs on router 5, the L2/L1 router, not on R3 and R4. Even though you can still technically leak a route and see it show up as down in the ISIS database on an internal router, such an example is confusing because it does not show the full results of a link, as could be verified by checking the routing tables of R6 and R7 if the policy were configured on R5. Okay, so I'll read this one more time, and I think this is going to be good. There's no reason to configure an ISIS level 2 to level 1 leaking policy on internal routers. The policy belongs on router 5, the L2/L1 router, not on router 3 and router 4. Even though you can still technically leak a route and see it show up as down in the ISIS database on an internal router, such an example is confusing because it does not show the full results of a leak, as could be verified by checking the routing tables of R6 and R7 if a proper policy were configured on R5. All right, so that's submitted. Happy birthday to the people at Juniper. So let's call it there. In fact, I went over 601, but yeah, so I will, I think I will work through the rest of these. I do get the sense that I'm spending a bit too much time on this. I probably don't need to do the BGP one because this is for IGPs, but, oh, and I probably don't need to do the LSPs one either because it's for IGPs, but these are probably pretty important, all 4 of these. So unfortunately, I think I am going to need to give another few videos to this topic. But next week, for sure, I'll be moving on. So thanks for watching and stay tuned for more.